Hi, this is my presentation for the graduate level um, section of data science, computer science 551. The presentation is titled Gender Representation in Video Games. This presentation and research were both created by me. So first, with our table of contents, I went with the IEEE paper layout. Made the most sense. Since if I did my presentation in this format, then that would directly translate to writing the paper. And it has made writing the paper easier. So part one, introduction, introducing the topic of gender and video games. Part two will go into research questions, what on that topic, spoke to me most to lead me to research it and dig into it. Related work, people that have done similar work and almost the same work. For this, it ended up being almost the same work. There aren't many people trying to use data science in particular for a topic like this. Methods is how I went about going through the data, finding the data, processing it, or pre-processing, processing, using it in the model, etc. The results will be what came of those methods, and then the discussion is just wrapping it up, talking about everything that came before in a conclusive way. So part one is our introduction. Video games have some of the worst representation stats out of all media types. Gender binary representation has 85.23% of all characters being male and females being the other 14.77% of characters shown. This stat would be for characters that make it on the screen, not necessarily a protagonist, but not something so minor that you would call them kind of like an extra on set or something. Stats on race, transgender identity, and sexual representation are even worse than gender representation, with a trend towards better gender representation in video games. This will be the metric focused on in this research. With this first statistic here, we can see that it is a gender binary representation. There is no third option included, just the two categories. So this is already, it's only looking at two categories out of many categories. Race is the only other comparable one towards, I would say, comparable in progress in current video games. Transgender and sexual representation have a long way to go. Continuing, when focusing on gender demographics, the main concern of this research is how inclusivity may or may not affect ratings of a game. Ratings will act as a scoring system in this research of general satisfaction with gender demographics and representation. Part 2, move on to research questions. Recent discussions have focused on social change and inclusivity. How does inclusivity affect a consumer's enjoyment of entertainment media? I'm going to move to this second paragraph first, real quick. The fourth highest grossing game of all time, World of Warcraft, has character customizability features where you can be many different sexes, genders, races, etc. Many of the top 100 games of all time also have customizability features. I mentioned this fact here to I see it as one of the easy ways to gauge that being able to see yourself in a game is a highly sought after feature of a game, even if it is not so conscious of a desire. So in World of Warcraft in particular, there's, I think, close to 20 different species you can choose from, of which most have two sexes. There are multiple genders to choose from. The races that I typed, I'm more specifically in a broader context would be species, but in the game's context, they're called races. And etc. You can customize whatever you want to about these characters, so that you can either see yourself in a game or you can see what you want to see of yourself in a game. And seeing yourself in a game, it can be validating in a lot of cases to have something you're looking for, but maybe not something you can act on. Changing your appearance in some way, or maybe you feel not cis, so your assigned gender at birth is different from how you feel. You could be in a situation where you can't act on that, and acting on that could be dangerous to your physical health, such as family or community. So these could be outlets for these people. Moving on to this first body paragraph is having a world focused on people that don't represent your experiences can be extremely isolating and have negative effects on mental health. Possible correlations between gender representation affecting ratings of games and being able to predict scores based on gender representation statistics will be focused on. This takes us to part 3 of related works. I gotta plug my laptop in. Okay. Much related work has been quantitative research. This is just to, preempt the research to say that it's not qualitative. Most of it is either pure data collection or data collection along with pure statistics. Look at these. And then these that I'm referring to of statistical looks at data are being referred to by articles, which then do more of a qualitative analysis, but the research in particular being done is quantitative. Start off with demographic data from 2015 to 2020. And a note that multi means there are multiple protagonists you can play, of whom the gender ratio is unknown, just meaning that a game could have two protagonists, one male, one female. It could have both male, both female, non-binary. It could be 19 females and one male, but because of the category of multi, this is something we don't know. So for analysis, we're ignoring the green part real quick. Not applicable. This is probably humanoid, but non-human, or just not even humanoid characters that you play as, where assigning a gender is just not good, easy, meaningful, whatever it may be. Then if we look at proportions of male to female protagonists, we'll see that in 2015 we start with 32 to 9, the ratio between male and female, which horribly decreases to 41 to 2 in 2016. But then we see a general following of 2015 for the next 3 years: 26 to 7, 24 to 8, 21 to 5, general same. And then on 2020, it's 23 to 18, which is an insane increase, and a much more stable, true representation, movement towards true representation of the people that are playing these. As in the US, it's 50.9% male and 49.1% female is the current demographics of the country. So we want to see a pretty equal balance between these two. And then another amazing note here is gender ambiguous and non-binary. Shows up for the first time in 2018 with 5% of the total protagonists. And pure speculation, I'm assuming that gender ambiguous is, more of an androgynous meaning, just an androgynous character, not necessarily non-binary. But I feel like as we move forward, especially in 2019, 2020, these probably mean more of non-binary than the gender ambiguous category. So aside from 2016 heading down, I see this as, we're holding steady, and then we are vastly improving. And then the presence of a gender ambiguous non-binary category is just really good to see. Research reveals decline in appeal of sexualized women in video games. Research performed by T. Lynch et al. For Indiana University's Media School showed that from 1984 to 2014, when the research finished, the critical success of games featuring sexualized female protagonists has decreased, while games with sexualized female characters showed no trend. Just in case that's a bit ambiguous, that's to say that, like I said earlier, with the extra characters, talking about not like on a movie set where you'd have extras, but just the characters of the movie, of all characters, whether or not the female characters were sexualized had no bearing, but whether or not the female protagonists were sexualized used to have more meaning, whereas now it contributes a lot less to the success of a game. And this is what this research found. One of their large research questions was to find out whether or not games with sexualized female protagonists in particular contributed to critical success. Critical success meaning, like, how do the critics take it, not how the users have been rating it. Sticking with the same study, we'll look at the sexualization index of female characters. This is the scoring system that Lynch et al. Made. Is their own scoring system that they've used to help. Is their own scoring system that they've used to help put into context all of this work, and see how these trends have gone over the years. So the sexualization of female characters over time has generally increased, but seen a declining trend in the past decade, from when this was performed. So between 2005 and 2014, at the end of the study, a large general decline in sexualization of characters in video games was seen. So I have two graphs over here. This is a year-by-year rating of the average sexualization index score. And then below it, we have this averaged into 8-year increments, time blocks 1 through 4. And you can see the years below each block. So we can see this general trend up here as well. If we take it 1 quarter at a time. So from 2005 at this peak right here down to 2014, averaging this together, there is a decent large decline in just the average sexualization index score of games per year averaged. Also important to mention for this study, since I'm talking so much about it, is that their method of data acquisition. So for the years 1984, which is the first year they could find to, have any data to start this study, to 2014, they eliminated games that were tied to franchises. Like a DC superhero fighting game, would have all of these superheroes from all the whole DC franchise. Those were all eliminated. And other ones that were purely sexual games, just like sex games, those were also eliminated. Then the remaining pool, they took 20 random members of each pool from each year to do the research on. And the research was playing the game for a certain amount of time, specifically at the time that a female character was being controlled by the user, and rating many aspects of the gameplay during that time period. It ended up being that 571 games were analyzed from this range of 84 to 2014. Last slide from this study. Gamers have it's the genre's effect on sexualization. So genres have a profound difference in sexualization of female characters, and player demographics follow the genre's sexual index score, where men make up a higher percentage of genres that score higher on the sexual index. So first, we'll look at this middle graph. This is just of those 571 games. This is where they fall into the 7 genre categories that were given. See that action category had the most, RPG and adventure, tank kind of for next, and then other shooter, platformer, fighting kind of being equal sizes. This graph right here is a violin plot of the genre, and they're based on, each pool. It's just the average of the sexualization index, and then plotted out. So we'll see that the largest is the fighting genre with a 2.92. And if I'm right, I believe the highest score is 4. So a 2.92 on the fighting index, or on the sexualization index for fighting, compared to the smallest one, which is shooter games, with 1/6 at 0.46, 1/6 of the sexualization index. The demographics within these genres is seen quite apparently. Women are more likely to play RPGs, shooters, and platformers, and least likely to play fighting games, whereas that's on a general basis. And then on an individual genre basis, the demographics for fighting games are vast majority male, and then action and the games that made it into other were next in that, then adventure, platformer, RPG, shooter. Like they followed the ranking of these games on the sexual index as to the ratio of men to women. This other graph over here is the proportion of primary and secondary characters across time. This is a look at whether or not the female character in these games is protagonist primary, so like you play as them and it's one of the main characters, or secondary, you might play as them a little bit, or you never play as them but they're around a lot. So we can see that in time block 1, which was the 80s, we had a near 50-50 split between protagonists and secondary characters. Time block 2, where most were in the secondary category, and then it's kind of balanced out onto a 40% are protagonists and 60 are secondary. Speculation on my part is that I feel like a 40-60 split is probably what the guy, the male category, sees as well for primary versus secondary. I just feel like that's probably a healthy balance between number of protagonists versus secondary characters. Part 4 is the methodology. So data acquisition. I got this data set from Kaggle under the title Gender Representation in Video Games, and I've included a screenshot of the first part of the page you see when you open it, and then this is a view of the preview of the data itself. Key points about the data set that I'd like to point out early. There are only 64 entries. It's the top 64 games between 2012 and 2022. I know that this is an extremely small data set, but as I will explain, throughout the rest of the presentation, I think this data set is good, is one of the best ones I could find for this topic to use, and that was more on the number of features it had than the number of entries that it had. Sets I found with larger entry sets had much less features, and I get into that later in the last section. So the dataset includes ratios of protagonist characters and development team gender identities. And the ratings are critic ratings and not user ratings. So that can be seen as either a good or bad part to this. Data cleaning, these were the steps I took. to clean up the data. Features with non-categorical text values were removed. Game titles, series, date of release, and game ID, which was an abbreviation of the game title, were removed. Features with categorical text values but no relation to gender were removed. This is genre, subgenre, developer, publisher, platform, country, and criteria, which criteria was bestseller, top rated, or both of those. Features with relevant categorical data were transformed to numerical categories. Customizable main character was changed from either yes or no in text form to 1 or 0, respectively, and gender of director was changed from M or F, male or female, to 0 or 1, respectively. Features with percentages were converted to whole numbers, so XX% was just changed into XX to keep the feature categorical and get rid of the percent symbol. And ratings were converted from a 10-star system to a score out of 100 to eliminate the decimals, creating a categorical system instead of a continuous system. This was so I could use it in Teapot later. Speaking of Teapot, TPOT, for feature engineering, most of that was left up to TPOT. For that, the CV was changed to a mean average error scoring system. It reports the error in negative numbers, so target number is 0, and of course the context of it dictates, what you can reasonably expect from mean average error. And since we're expecting top-rated games on a score of 100, it's about 90, so you would want a variance of probably 1, 2, or 3. So you want a mean average error probably around -1.5, -1, preferably 0. But and then I've included the the formula for calculating the CV. And then TPOT was calculated with the following code. I just included all of it. Most of it was taken from the lab we did in class. I've changed a little bit of it, some to save time, some in the interest of hopefully achieving a better model. Model development. Using TPOT 5 different times with slightly edited input parameters yielded 3 different model types. The models were MLP classifier, multinomial NB, and decision tree classifier, the best of which was the multinomial MB with a mean average error of 3.39. Model training. The model was trained using the model generated by TPOT. The selected features were age rating, also called PEGI, P-E-G-I. That's like E for everyone, T for teen, 18 up, that customizable main character flag, percentage non-male characters, percentage non-male protagonists, director gender, and percentage non-male development team members. All of these say non-male instead of female, so as to include females, and then also those not identifying with a gender binary. The code generated for the MLP classifier was, as is written here, alpha 0.0001, learning rate of 0.5. The model evaluation and validation. Evaluation was performed using cross-validation and accuracy score from the metrics library. Success rates of 96.8 and 96.7 were found with these methods. These were from 2 different validation processes. So validation was done by checking predictions versus actual and residual mean and error, as shown in the graphs below. The residual mean error graph is centered around 0 with a near bell curve distribution showing a good result for distribution of predictions. The spread of the residual normality and mean residual error graph is wider than we would hope it is. A graph where -10 and 10 were not the markers, instead -5 or 5 or even smaller would correlate with a better percentage score for this. And then the actual versus predicted value graph is here. Validation continued. The multivariate normality was also checked and found to be a linear distribution, which is what is expected of models, and is what we want to see. Deployment. So the model was deployed exclusively on Streamlit. During our lab, we used Heroku, but the free version ended, so I transferred my method to just using Streamlit, and it worked just fine for me. It was pretty easy. A good transition between the two since we'd already started on it. Section 5 with results. A testing of a k-neighbor model with a range of neighbor quantities 1 through 49. Selected its highest score at 38 neighbors with a score of 12.7% success. And other models found by Teapot yielded similar scores at 12.5, 13, and 10.8% success. Feature importance, the R-squared value obtained, feature importance is calculated using the R-squared value. The R-squared value that was obtained was 0.125 or 1/8, which shows that an increase in input data yields a proportional increase in the rating at a rate of 8:1. Therefore, the input data has some significance to the rating, but maybe not as much as hypothesized. For runtime monitoring, I had two of my classmates, Ray Arndorfer and Zach Wesky, try it out, and these were their responses. So I'll read them. For Ray, they said, as I adjusted the input parameters, the estimated score would change, but there wasn't an apparent pattern I could see. While moving a parameter's sliders up, it wouldn't necessarily change the score only in one direction, which brings up questions of the importance of those parameters. So Ray did not have any trouble with the speed of deployment, no latency. He did notice inconsistencies with the prediction parameter adjustment, which could easily be valid in the prediction process or caused by the small data set. This is just to say that it's not necessary that given the rest of the parameters be static, if you adjust one in one direction, then the final prediction is going to move in one direction as well. Moving the other parameter in one direction could result in fluctuating values for the prediction. Zach said, the parameters would immediately alter the prediction. The predictions all stayed in the decently high number range from around 85 to 95, which I assume is a result of training data with high ratings. So that's completely right. The training data did have high ratings, so Zach was right in this assumption. And he didn't have any latency with the live predictions, which is very good. The high ratings was due to these being top-rated games of the last decade. So the predictions are only valid for a high-quality game, and it's really only going to yield high ranges and accuracy below that. It may be able to detect what will go below, but it would not be accurate in where specifically that would rate. And our last part for discussion is answers to research questions. So there were not many answers yielded from this. Sadly, conclusive evidence could not be found between the dataset and the questions posed, despite current research manually yielding answers to these questions. Research that I've put in my works cited at the end of this each have come to some sort of conclusive evidence. So it's possible. I just think that a larger data set for this is needed specifically, for a data science perspective on this. So for our first question, do games with higher gender representations receive better critical success? A correlation to the question could not be found. This is likely due to the method of obtaining data. Since all the games were top-rated games from the past decade, game data that would have helped answer this question was likely missed in data acquisition. The diversity of quality of games was very low, so a higher diversity of quality of games would likely yield better answers. And for the second question, can gender representation data be used to predict the critical score of a game? The model came close to predicting the scores of the test data, but this could be because of a close spread across the scores, with all games being top rated and top sellers of their release year. With the teapot algorithm for AutoML yielding a 3.4 mean average error, and our range of valid scores being between probably 85 and 100, that would mean that if you're trying to predict 92, you're probably going to get 89, anywhere from 89 to 95, which is really not a great range since it's covering much of the range of possible scores. So I think this was likely one of the reasons that the model seemingly came so close in a range of 0 to 100, but really it's a range of 85 to 100, so it didn't come terribly close. So limitations, obviously, were the dataset size. The dataset was chosen knowing that it was an extremely small dataset, and despite its size, it was chosen due to its possible applications in this research. Other datasets were either had many listings, but not a lot of features, or had a lot of features, but had even less listings of games. And then current knowledge of machine learning tool sets, I think I could do a lot better, even with this small data set, with an even deeper understanding of machine learning tools than I currently have. With my current understanding, I think I'm just not fully prepared to handle this, but I believe this is a handleable data set. So future work, moving forward, the focus of this research will be to gather a much larger data set and retry the work that's been shown in this presentation and done by me. So with this larger data set, preferably to start with the same features, but I'll also collect more features. And this will be done to get a much clearer picture as to whether or not an interaction exists between inclusivity and satisfaction while gaming. Teresa Lynch, the first name listed on the research that I discussed most during previous work. She is one of the authors and one of the researchers for that paper. I have contacted her in hopes of gaining access to the data generated by her team during their research. With 571 games looked at, if they had some sort of Excel file or a CSV or a JSON with all of this data in it, or even a much less viable file type, having that data would be extremely beneficial to doing research into this because of the sheer amount of time that they had to put into collecting that data in the first place. I think they spent anywhere from 5 to 10 minutes playing each game of 571 different games. Let's see, if I round that to 600 games, 3,000 minutes, which is just a lot of work, an insane amount of work that her team did. So if it's possible to get access to that and possibly merge that with my data set and further flesh out that data set, that would be extremely awesome. And lastly, the research will expand from just focusing on gender to focusing on all types of demographics such as race, sexuality, and transgender identity. This is also in hopes of finding the connection and being able to prove that connection, because current research shows that that connection is there. It's just a matter of creating a fully fleshed out data set that can actually prove that that connection is there. So this is what I hope to continue to do, and I do truly honestly hope to continue to look into this and continue to flesh out this data set as I move forward, even not being in this class anymore. After reaching certain milestones, I'll be uploading this to Kaggle. Professor, I'm sure I'll email you about it so that if you were interested or another student were interested somewhere later in the future, they would have access to that. So I do plan on getting further into this data set and hopefully find something conclusive and teach myself a lot more about this field. Lastly, the works cited page. These are the articles and papers that I've referenced in here. But that is all for me. That is my research. I am looking forward to submitting my paper and hearing back from you or hearing any feedback about this if you have any of that. So thank you very much, and thank you for teaching the class. I've enjoyed it a lot, and I hope to see you around. Thank you very much.